We have two kinds of special right triangles. We have the isosceles right triangle. That's also known as the 45-45-90 triangle because its three angles are 45 degrees, 45 degrees, and 90 degrees. And we have the 30-60-90 triangle. These special right triangles help us because we can use relationships between their sides to help us find missing sides without using the Pythagorean theorem. So for instance, on the 45-45-90 right triangle, what this diagram is trying to show us is that the two legs that make the right angle are the same length, and the hypotenuse across from the right angle is always the leg multiplied by the square root of 2. Now, if we knew the leg, we could use the Pythagorean theorem, a squared plus b squared equals c squared, to find a missing side. But this is just so much easier and quicker that it's really helpful to know these shortcuts. So in this example right here, they're telling us that one of the legs has a length of 4. Well, since it's a 45-45-90 triangle, by the way, if we have a 90 and a 45, we automatically know that the other angle is 45 because they have to add up to 180. If one of the legs of a 45-45-90 triangle has a length of 4, we know the other leg has a length of 4 also. So this side here would have a length of 4. And the hypotenuse across from the right angle must be the length of the leg multiplied by the square root of 2. And that's it. And we're able to find these missing sides without using the Pythagorean theorem. On the 30-60-90 triangle, what this diagram is showing us is that, well, first of all, notice that a 30-60-90 has one short leg and two long legs, and one long leg, and those two legs together make the right angle. And across from the right angle is the hypotenuse. So what this diagram is showing us is that the longer of the two legs is equal to the shorter leg multiplied by the square root of 3. And that the hypotenuse is always 2 times the shorter leg. So in this example here, they tell us that the short leg has a length of 3. So that means that this long leg must be the short leg multiplied by the square root of 3. Or 3 times the square root of 3. And the hypotenuse must be 2 times the short leg, or 2 times 3, which equals 6. So let's try a few of these examples here. So on this 45-45-90 triangle, they tell us one of the legs. The other leg must be the same length. The idea there is if two angles are the same, the two sides must be the same also. And then the hypotenuse across from the right angle, well, that's going to be the length of one of the legs multiplied by the square root of 2. Okay, this one here is a little bit different because this time they tell us the hypotenuse. Well, up here, if we know the leg and we're looking for the hypotenuse, we multiply by the square root of 2. So here, if we're going the other direction, and we're trying to find a missing leg, we'll divide by the square root of 2. So that would be, let me write it over here. You'll see why in a moment here. 18 divided by the square root of 2. Now, unfortunately, we are not allowed to leave square roots in the denominator of a fraction. So there's a method that we can use to rewrite this fraction without square roots in the denominator. We're going to multiply by this exact square root on the top and the bottom. So what we're doing here is we're multiplying by a special version of the number 1. And when we multiply by 1, we're not changing the value of the fraction, but we're going to change the way it looks. All right, when we multiply fractions, we multiply straight across the top. So that'd be 18 times the square root of 2. Okay, now here's where the magic happens with this method. The square root of 2 times the square root of 2, well, that equals the square root of 4. And the square root of 4 equals 2. That always happens. If this was if it was the square root of 17 times the square root of 17, it would be 17. All right, so almost done here. We have, by the way, we cannot cancel these 2's because this 2 in the numerator isn't really a 2. It's the square root of 2. But there is something we can simplify. The 18 and the 2 are both regular numbers, and 18 divided by 2 is 9. So we go ahead and do that. And when there's nothing left except a 1 in the denominator, we can get rid of the fraction part, or get rid of the denominator. Right, so if the hypotenuse has a length of 18, then the legs must be 9 times the square root of 2. Right, on the 30, 60, 90 over here, if we have a short leg is 4. Well, let's do the easy one first. The hypotenuse across from the right angle is 2 times that. So that'd be 4 times 2, which is 8. All right, show my work here. 4 times 2 equals 8. And then the long leg is just the short leg multiplied by the square root of 3. Remember, it's always the square root of 3 on a 30, 60, 90. That's just how it works out. If we did that with the Pythagorean theorem, we'd get the same thing. So 45, 45, 90, we use the square root of 2. 30, 60, 90, we use the square root of 3. Different situations, though. All right, here we have another 30, 60, 90 triangle, but this time we're told the hypotenuse. Well, remember up here, we multiplied by 2, multiplied the short leg by 2 to get the hypotenuse. So here, if we know the hypotenuse, we can get the short leg by dividing by 2. So 50 divided by 2 is 25. So short leg has a length of 25. Then the long leg is, well, that's the short leg multiplied by the square root of 3, just like here. So that would be 25 times the square root of 3. If you're ever given a 30, 60, 90 triangle and you don't know the short leg, figure the short leg out first, because everything kind of is controlled by the short leg. Well, it's easier to do it that way. Okay, so here's the hardest version. We have a 30, 60, 90, and we know the long leg. Okay, so we're always going to figure out the missing short leg first. All right, so here we multiplied by the square root of 3 to get the long leg. So if we know the long leg and we need to get the short leg, we'll divide by the square root of 3. So that'll be 15 divided by the square root of 3. Once again, unfortunately, we're not allowed to leave square roots in the denominator. So I'm going to multiply by my special version of the number 1. This time it'll be the square root of 3 over the square root of 3. So I'm just multiplying by a fraction that equals 1, not changing the value of the fraction. It's just going to change the way it looks. Okay, multiply across the top. I can't multiply those because the 15 is a regular number and the 3 is a square root. So we just attach them. That, by the way, that really means 15 times the square root of 3. We just don't write the multiplication sign. Square root of 3 times square root of 3 equals the square root of 9, which equals 3. And remember, that always happens. That's why we did this. Okay, we cannot cancel those 3's because that's not really a 3. It's a square root of 3. But we can do 15 divided by 3. By the way, you don't always have to simplify these if they don't have a common factor other than 1. So let's see, 15 divided by 3 is 5. So we're left with 5 times the square root of 3 for, let's see, where am I here? The short leg. So that's here, 5 times the square root of 3. Now that we know the short leg, we can multiply it by 2 to get the hypotenuse. So let's write it this way. 2 times 5 times the square root of 3. Okay, remember this is really 5 times the square root of 3. So looking at it that way, we just multiply the 2 times the 5. We're not distributing or anything like that. So that would be 10 times the square root of 3. Okay, so we were told the long leg. We divided by the square root of 3 to get the short leg, and we had to do some simplifying. Then we multiplied the short leg by 2 to get the hypotenuse. All right, there we have it. Signing off.